we have y equals -2 multiplied by 3 raised to the power of x plus 4 minus 2. So when you're graphing exponential functions, you always have to start by identifying the parent function because that can change. So in this case, our parent function is going to be 3 raised to the power of x. It's always your b value and the value of x, that's it. You don't want negative signs with it, you don't want multiplying values, you don't want anything with the exponent, just 3 to the power of x. So off to the side, I'm going to write the parent function and I'm going to make my table of values. So I always use the same 5 points. I start with -2. 3 raised to the power of -2 is 1 over 3 squared, which is 1/9. -1, the output is 1/3. 0, 1, 1, 3, 2, 9. So these are your parent function points. I'm going to graph these on the graph, and then we're going to talk about all the parts of the parent function before we do the transformations. So I have a point at -2 1/9, -1 1/3, 0 1, 1 3, 2 9. And the graph looks like this. Okay, this is not our final answer, but I just want to take a moment to explain the parts. So one of the biggest things about graphing exponentials is what we call a horizontal asymptote, and it's the line that the graph touches but never crosses or intersects. I don't know, sorry. Oh, here we go, okay. So that's your horizontal asymptote. That's where it always starts. So every parent function has that horizontal asymptote at the line y equals 0. This line shifts up or down with the graph. So if you are shifting the graph up, that line will move with it. If you're shifting the graph down, it will move down with it. But that's where it is. So if I was to ask you all the key parts of this function right here, if I was to say, what's the domain of this function? You would hopefully say that the domain is -2 positive infinity. So the graph extends in both directions, to the left and to the right, which is where you get negative to positive infinity. But the range of this graph is restricted. So the range never goes below, or this graph, the black line that I graphed, never goes below that highlighted green line on the x-axis, so the line y equals 0. It never touches that line, it never crosses that line. So it's getting closer and closer and closer to that line at 0, but it never actually intersects it. So we're going to say that the range is from 0, not including 0. So even the tiniest bit larger than 0, just not including 0, all the way to positive infinity or extending on forever. So you have to use a round bracket with range. It never receives a square bracket because it can't actually touch that value. The range is never 0. It's slightly over that. Okay, these are the key parts of the parent graph, but now we need to transform it. So this isn't going to be our final answer. I'm going to actually erase this. I just wanted to make sure we explained where the info comes from. And I need to look at my transformation. So let's start with the transformation of your left or right shift. Right here I have +4. If you're adding 4 to the exponent, that's going to be the first step, and this is telling you to shift the graph to the left 4 units. So I'm going to go ahead and do that in the orange marker. So left 4. This is step 1 of the transformations. After you shift the graph to the left 4, you need to look at your a values. So what's going on in the a category of the function? That would be right here. We have -2 as our a value. This actually tells us to do two different things. So it doesn't matter which order you pick to do this in, but we have a reflection across the x-axis. And we have a stretch by a factor of 2. It's a vertical stretch. So if you're stretching vertically, you're multiplying the y coordinates by 2. It doesn't matter which order you do these in. I guess I'm going to start with the stretch. So we'll do the vertical stretch first, and then we'll do the reflection after. You can do them at the same time. In fact, if I was doing this by myself, I would do it at the same time, but for explaining right now, I want to make sure we go over both of them. So I always do the vertical stretch right in my head, but you can multiply your y coordinates in the table by 2 if you would like to. I'm going to start at this point. That point has a y coordinate of 1/3, so 1/3 times 2 would be 2/3. So I'm going to replot this point at 2/3. Oh, that's 1/9. Sorry, 1/9. That would be at 2/9. The next one is at 1/3. 1/3 times 2 would be 2/3. This point right here has a y coordinate of 1. 1 times 3 is 3. It should be 1 times 2. 1 times 2 is 2. Right here we have a point at 3. 3 times 2 is 6. And that last point's going to actually fall off the graph. It's going to go too high. So I'm just going to graph these few that I just sketched. It still gives me enough to get the general form or the general shape of my graph. I keep sliding this. It's kind of... Now I need to reflect this graph. So if this point right here is 2/9 above the x-axis, I go 2/9 below. This point is 2/3 above, I regraph it at 2/3 below. This point is 2 units above, we go 2 units below. Here we're 6 units above, regraph that at 6 units below. And our final step when we're graphing is this right here. It is your up or down shift. In this case, this is going to be step 4. This is a shift down 2 units. So I take the last step I was on, which is this graph here, and I shift every point down 2 units. When I shift my graph down 2 units, it also shifts the horizontal asymptote down 2 units. So this line is going to move down 2. Not only does the horizontal asymptote move down 2 units, but the domain and range follow along with that. Of course, the domain is all real numbers, so it really only affects the range, but that does happen here. So for this function, I'm just going to label those 3 parts. The horizontal asymptote moved down to -2. If I was to list all of these, I have a horizontal asymptote at y equals -2. The domain is -infinity to +infinity. And now the range, this one's a little bit tricky because this graph is actually heading towards -infinity. While it's probably tempting to write -2 to -infinity, because that's the way you would look at this graph, you need to make sure you put the most negative number first. So it's -infinity to -2. That means this graph is approaching, so it's starting at -infinity, it's coming up, it's approaching this line, but it's never actually touching or crossing that line at -2. Also, whatever your asymptote is going to match your range. That will happen every time.